Here we see some actual data from our class. Now this is from a couple of weeks ago. It hasn't been updated since then. But what you'll see on the y-axis is a student's grade, and on the x-axis is how many days they have missed. So what I want you to do is I want you to just look at this graph for a minute and tell me what you notice. In this video, we're going to be looking at scatter plots, determining if a scatter plot displays positive, negative, or no correlation, and we want to distinguish between correlation and causation. So let's go back to our grades versus days missed graph, and you can see I've drawn this blue line through there, and in fact here you see the equation for that blue line. And that blue line, I hope, sort of matches your intuition about what was going on here, is that there is a line that you can sort of draw through the middle of this that kind of defines what's going on here. In particular, as the number of days you miss increases, your grade goes down. And so that's sort of a relationship that we can see between the number of days missed and your grade. And in fact, the fact that there's a relationship between these two turns out to be exactly what we're looking for in this lesson. So first of all, a scatter plot, which is what you were just looking at there, that graph that I showed you. This graph right here is a scatter plot as well. It's just a graph created from pairs of numerical data. So in this example, I've got temperature, which is numerical data. I can represent that with numbers. And I've got ice cream sales. How much ice cream gets sold? I can represent that with numbers as well. And each one pairs up to each other. For example, this is the amount of ice cream sales when this is the temperature. So I've got two different things that I call variables, and they are connected, so I took the measurement of them at the same time, and it's numerical. And any data like that I can put into a graph and take a look at, and we call that graph a scatter plot. And the entire point of a scatter plot, the reason we create these, is that we use them to find relationships between sets of data. For instance, if I have this table right here, I have all these numbers and I have all these numbers, and human brains are not particularly good at looking at a set of numbers like that and saying, oh yes, I see the relationship. However, if we graph all of these points all on the same graph, and it looks something like this, then we can very easily, with our eyes and our mind, pick out the pattern, and we can see that as the temperature goes up, the amount of ice cream we sell increases, which, if you stop and think about it, makes sense. When you want ice cream? When it's hot outside. A correlation, which is really the thing we're looking for in these scatter plots, is just a fancy name for a relationship between the two variables. So if there's a correlation between two variables, that means there's a relationship. There's something I can say about what happens to one when something happens to the other. If we're looking at what's called a positive correlation, when the value of one variable increases, the other variable increases as well. So if we look at the number of sunglasses sold versus the profit from ice cream sales, what we can see is that the more sunglasses you sell, the more ice cream is being sold. And so we can say that there is a positive correlation between these two, because if you imagine drawing a line through this, that line has a positive slope, if you think back to slope, man. And so if the line that we can draw through the data, called the line of best fit, has a positive slope, we say that it is a positive correlation. When one increases, so does the other. And by graphing these paired up sets of numerical data, I can find that relationship between them, which is kind of neat. We could also have what's called a negative correlation. So if we go back to the grade versus number of days missed, if I draw the line through this one, it sort of looks something like that, only, straight. But this, the line going through it would have a negative slope, and we call this a negative correlation, because as the value of one variable increases, that is, as the number of days missed increases, the grade decreases. So if one increases when the other decreases, we call that a negative correlation. And it works the other direction as well. We can see that as our grade increases, the number of absences is decreasing. So they have sort of that opposite relationship. Now that's what we can find if there is a relationship between the two. It's also possible that there is no relationship between the two variables. And when this happens, we say there's no correlation. So if you look at this data, which shows how long it takes someone to tweet out 200 tweets, and this is the number of retweets they get for those 200 for a random sampling of data, we can see there's no connection between how fast you tweet out things and how many retweets you get. And so by knowing there's no relationship to that, or no relationship between those two variables, it can inform, say, how you use Twitter. So if there is no detectable pattern, there's no line I can draw through this, there's no shape in this graph, we say there's no correlation and there's no relationship between the variables. So to sum up this correlation, and remember, a correlation is just a relationship between two variables, whatever those variables may be. If the scatter plot is generally upward like this, we say that's positive correlation. If it's generally downward in that direction, we say it's negative correlation. And if it just looks like a shotgun blast and things are everywhere, we say there's no correlation whatsoever. There's no relationship between those variables. They are disconnected. Now, one thing you have to be extremely careful of, and I cannot stress enough, is that just because there is a relationship between two variables does not mean that one causes the other. And so the way this is said is that correlation is not causation. Correlation is a relationship between two variables. Causation means that one variable causes the other. And I'll give you 3 examples of this just to show you that because things are correlated doesn't mean one causes the other. If you look at the time of year where ice cream sales are the highest, that is the exact same time of year that there are the most deaths from shark attacks. Buying ice cream does not cause you to get eaten by sharks. Or the other way around, getting eaten by sharks does not cause you to eat ice cream. In fact, I don't know that I'd be worried about ice cream at all if I was looking at that. So these two things are correlated. There is a relationship. It is absolutely true that most ice cream is sold during the time where there are the most shark attacks, but there is a separate reason for that. It's that they both happen during the height of summer, when most people are at the beach, when more people are in the water. Of course there are more shark attacks. And when there are more people at the beach, it's because it's warm outside, and when it's warm outside, you want ice cream. So these two things are correlated. If we were to plot a graph of ice cream sales versus shark attacks, it would totally have positive correlation, but one does not cause the other at all. So correlation is not causation. Here's another one that lends itself a little more to reality, I guess, is that if you look at the part of the world where rice is a staple food, you'll see a lot of people with very beautiful jet black hair. And so if we were to draw a scatter plot of number of people with black hair versus amount of rice eaten in a certain amount of time, there would be a positive correlation. However, one does not cause the other. Having black hair does not cause you to eat rice. Eating rice does not cause you to have black hair. It's simply that the location in the world where rice is easy to grow and is a staple food is the same location in the world where people are genetically predisposed to having that black hair, namely Asia, India, and that area. And so, again, correlation is not causation. One does not cause the other. They just happen to show up in the same place. And now to really bring this home with maybe the scariest example of this. You may think that people don't actually confuse these things because the last 2 examples I gave were just kind of ridiculous. Nobody assumes that eating rice causes you to have black hair. Nobody assumes that eating ice cream causes you to be eaten by sharks. But sometimes we do make this mistake in kind of a scary way. Autism is a very, very broad kind of disorder that affects the human brain in kind of interesting ways, and it kind of impairs social interaction, but at the same time it kind of ramps up your perception skills. A lot of times it's associated with higher math ability, but it is a disorder that is not well understood and can be a little bit scary as somebody who is a parent. You get concerned for your child and for the way they would interact with the world if they're facing autism. And the thing is that autism, the symptoms get noticed right around 2 years old. So starting at about 6 months and going all the way to 2, 3 years old is when you first start noticing the symptoms of autism in children. Well, at that same time, between 6 months and 3 years, is when a child gets all their vaccines. Now, this has been studied extensively. Vaccines don't cause autism, yet they appear at the same time, which has caused a lot of people to be very concerned and to not get vaccinated. And when those people have not gotten vaccinated, what has happened is that some diseases that were almost eliminated, like the measles and the mumps, that were very serious health issues in the past that were almost eliminated, those diseases have started coming back because people have seen this correlation between when children get vaccinated and when they develop autism, and people got confused thinking that vaccines caused autism, which is not true. And so if we get causation and correlation confused, sometimes it can lead to some situations that are frankly kind of scary. So keep in mind, just because there is a relationship between two things does not mean that one causes the other. There may be some other factor that is connecting those. So again, with scatter plots, remember scatter plots are just used to find a relationship between two things. We can have a positive relationship, a negative relationship, or no relationship. We call that relationship a correlation. And folks, please remember, correlation does not equal causation.